I'm sorry, guys. I'm sorry, guys. It took me a minute to come back. Somehow it won't let me in because it was downloading the previous session, but we're back. Don't worry. I apologize. Let me go back to your text. 11.2, we are going to work on some of the problems. And you can see these problems are not really that difficult. Very routine. Okay. Now let's see what numbers I've assigned. 11.2. 1 through 3, 8 through 13, 15, and 16. 1 through 3. So we have done those 1 through 3. 8 through 13. 8 through 13. Okay. I think we did 8, 8, 9. We did 9, 8 through 13. Okay, here's a good one. Draw lines of symmetry if they exist for each of the following figures. Now, on the exam, I may ask you to draw lines of symmetry, or I may ask you to tell me how many lines can be drawn. So be aware of that. So I'm going to take this guy. I'm going to put it here. I can only draw one line right through the middle for this one. For this one, I'll bring it back, okay? For this one, I can draw more than one line. I can draw more than one line. And for instance, I can draw this line. I can draw this line. And my line's not perfect, and that's okay, as long as we understand the concept. Okay? The first shape has reflectional or line symmetry. And how many lines of symmetry are there? Only one. The second shape has reflectional or line symmetry. How many lines can be drawn? The answer is 5. Okay? That's that. Number 10, then 13. Okay, look at this one. Various international signs of symmetries. Determine which of the following figures, if any, have the lines of symmetry. Okay, turn symmetry and or point symmetry. Okay, we didn't study turn symmetry. Don't worry about turn symmetry. I would say the first shape has line symmetry. Okay, also has point symmetry. First shape, we just studied two. Okay, just focus on two. That's okay. This shape actually has both point and line, both. Okay, now if you rotate it around the center, this falls on itself. This falls on itself. And its angle of rotation will be 360 degrees. 360 degrees divided by, it has 4 equal parts, right? 4 equal parts divided by 4, and you're going to get 90 degrees. So they didn't ask for it, but it's something we studied, might as well do it. So that's that. How many lines are there that can split the shape? 1, 2, 3, not perfect, but you get the point, hopefully. And 4, not perfect, but you get the point. Okay, so this shape has both line symmetry and point symmetry. And how many lines can be drawn for? What is the angle of rotation for point symmetry or rotational symmetry? 90 degrees. Gonna give you guys a minute. Pause here just for a minute. Okay, guys, let's see what else is coming up. This shape has only line symmetry right through the middle, vertical line. Okay, I'm not going to worry about it. I think you understand it. Find all the line symmetries of the figure in exercise 11, which we did. For the left-hand side, there are four, and for the right-hand side or part B, there's only one right through the middle, which we kind of did. Number 13, design symbols that have each of the following symmetries, symmetries if possible. Line symmetry, but not turn symmetry. Okay, so I would say the letter A. If I design, I know I'm being a little lazy, but you can design anything that looks like A that will have line symmetry, but not point symmetry. Turn symmetry, but not point symmetry. Let's not worry about it. We didn't talk about turn symmetry. Rotational symmetry, but not line symmetry. That would be the recycling bin sign that has rotational symmetry, but it doesn't have line symmetry. So I won't ask you to design anything, but we did it. Number 13, what else is here? 15 and 16. Let's look at 15 and 16. Okay. Which of the digits 0, 1, 2, 3, 4 have the following symmetries? Take a look. It's very similar to the letters we talked about, right? Line symmetry, point symmetry. Which of the digits 0 has line symmetry? Does it have point symmetry? Yes. You can, if this is a kind of oval shaped 0, you can turn it around half a circle and it will match itself. 1 has no line symmetry, has no point symmetry. 2 has no line symmetry, no point symmetry. 3 has no point symmetry, but it has a line symmetry. And if you draw a line, horizontal line right through the middle, the upper half and the lower half will be mirror image of each other. They will match each other like the palm of your hand, like your palms. 4 has neither. Let's see if people have questions on number 15. Let me bring it to the next screen page. People really understand. Now, if I give you something like this on the exam, guys, I'm going to give you different numbers, right? You really want to understand it. Make sure you do. And we'll do the next one, and you'll see we have discussed all the things you need to answer 16. It's a little hard to do on the computer, but it's not bad. And I'm not complaining, but let's try number 16 carefully. Determine the measures of angle of turn symmetry for. I wonder if they're using the word turn symmetry for as point symmetry. We're going to pretend they're talking about point symmetry, okay? So we didn't do turn. I'm not going to use that word. It almost seems like they're using it interchangeably. But take a look at the first one, guys. First one, I am going to turn it around the center like so. First, let me test if it has turn symmetry. It does. And I'm going to take this shape, draw it right here. Take a look. It does rotate onto itself right here. Quarter circle, half circle, it matches. I rotate it half circle, it matches. Another way to see it, since it has rotational symmetry, it has two equal parts. So if you take 360 divided by 2, you're going to get 180 degrees. So let's write it down somewhere. This shape from your book has two equal parts around the center that match. So you're going to take 360 divided by 2, you're going to get 180. That's your angle of rotation. Let's do the next one. Let's do the next one, this one. And how many sides does it have? Let's see. This has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. Okay. So it has rotational symmetry. If you move it like a steering wheel of your car, it will match itself before you make a full circle. So how many parts are there that will match itself? There are 9 parts. So you're going to take 360 and divide it by 9. And the angle you're going to get is 40 degrees. So the smallest angle you have to rotate the shape so that it matches itself is going to be 40 degrees. Okay. Let's see, guys, if we have any questions. Any questions? We have a little bit of time, guys. So we are officially done with 11.2. Okay. So let me tell you a couple of things. Officially done with 11.2. We practically did all the problems from 2A. You should be able to do 2B and MATLAB. These two problems, I'm going to work on these two problems. They're from when we were meeting face to face from that time. And these two problems were not done. We did this in detail. Now, part C, we did part D in detail. We didn't do these two. Let's do them, A and B. Okay, so be a little patient. I'll do it. Kind of we are backtracking. All right. So let's read. Find the area of each of the following shaded regions in parts A through D. Assume all arcs are circular. Leave all answers in terms of pi. I'm going to work on A first. Okay. In figure A, I have a large circle and two little circles inside. If the radius of the little white circle is 1, the radius of the big green circle has to be 2. I'm going to make this red so that it stands out. The radius of the big, which is partially shaded green, is 2. So what I'm going to do, guys, I'm going to find the area of the big circle. Okay. Area of the big circle is going to be, remember, guys, that formula pi r squared. Pi is just pi, 3.142. R is the radius, and that's squared. What's the radius? The radius is 2, not 1. So I'm going to say pi r squared. And r is 2. So it's going to be pi 2 squared, and which turns out to be 4 pi. So the radius of the big circle is 4 pi. Sorry, area of the big circle. What's the area of the smaller circle? So I'm going to say total area of the two smaller circles is what, guys? Same story. You're going to take your pi But this time your radius is going to be 1. So I'm going to make it a small r, a big R. And I'm going to stick a 2 here because I'm looking at two circles, 2 pi r square. Pi r square is the area of one circle, 2 pi r square because there are two white circles. And this is going to be 1 squared, 2, and this is going to be 2 pi. If you simplify it, 1 square is 1, 2 pi times 1 is 2 pi. You have everything. So what I'm going to do to find the area of the green shading, green shaded region, the area of the green shaded region is going to be the top number 4 pi minus 2 pi, the smaller white two circles, area of the two circles, and that's going to give you the answer. And we have everything in terms of pi, so we are okay. That's how they want it. Excuse me. Do it here. I'll pull it down. 4 pi minus 2 pi is equal to 2 pi. Now, that's my answer. My unit will be centimeters squared. Let's put it right here. Unit will be centimeters squared. cm. You can write SQ, SQ, cm. That's fine. But I'm just going to be fancy. I'm going to write centimeters squared. Squared. So that's your answer. Take a look. Take a look. I'm going to give you a couple of minutes to process it literally, okay? Because you really want to see how I found the area of the big circle, how I found the area of two little circles, the white circles, and why I subtracted the two to find the area of this funny green shape. Okay, guys, let me try part B. I do need the extra room, so I'm gonna delete some of these, if that's okay with everyone. Okay, here they want you to find the area of this green shape, which is really a triangle plus a semicircle. And hopefully we have the formulas to do both. Okay, so I have to find the area of the semicircle. I have to find the, I'm sorry guys, my email is beeping. My apologies. So let me see what I can do. Let me get out of here so that you don't get distracted by it. Okay. So guys, I'm gonna do part B, and part B isn't that bad. It's very direct. You have to find the area of the semicircle. Semi is half, and the radius is 1. They have labeled it for you. So you're gonna say something like this. The area of the semicircle is your same old formula pi r squared, but you have to divide it by 2 because you're finding the area of half of it. So you're going to say something like this. Pi r square divided by 2. Don't forget to divide by 2. Do it right away from the very beginning, okay? Don't say I'll do it at last. I'll find the area of the whole circle. I divide the answer by 2. You might forget it. So r is 1. I'm going to put a 1 here. I'll put a 1 here. And what do I get? I get pi over 2. So far, we have only completed the semicircular part. Okay? Okay. Now, let me double check if I made a mistake. I don't think I did. Now I'm going to find the area of the triangle. Area of the triangle, right triangle. Area of the right triangle. Now, when we did the grid problems, find the area, that's what we did. This line, which is 1, times this line, which is 2. 2 times 1 is 2, and then divided by 2 because it's a triangle, you want half of the rectangle. 2 times 1 will give you the area of this rectangle. Okay? 2 times 1 is the area of this rectangle, pink rectangle, but you don't want the whole rectangle. This is a 1 here, right here. This radius is 1, just like this radius. So your answer will be 2 times 1 divided by 2, which is 1. Almost done. Almost done. I don't need this. Okay. Area of the semicircle, we got it. Area of the right triangle, we got it. My final answer should be pi over 2 plus 1. Pi over 2. And my unit is going to be cm squared. And you can put a parenthesis if you really want to be proper. That's my answer. Final answer. So we did number 20 completely, fully, and we have everything here. Let's take a look. Let's pause here just a little bit and see if we have any questions. So, guys, I don't have anything else for today. Let's stop here, stop lecturing here, but I'll be happy to be around to take your questions if you have any. If you want me to do some practice problems, I think I uploaded, let me see what I uploaded. Not a bad time to check. So, here, let me see what I uploaded. So, you have this 4-petal problems. You want to practice them, guys. Okay. Answers are here. So, these are very important problems. Anything, I think I uploaded some of the harder ones and the stuff we did from this section today, mainly symmetry. Those are very routine, very basic. 11.2 is probably one of the easiest sections in the book. I'm glad we did it while we were teaching online because it's a little hard when you are not in class, but we have more sections to go through. Don't worry. Any questions, guys? Any questions about the content and where things are, what we are doing, what we have been doing? If you want to leave, feel free to leave. I'll be here. See if people have any questions. Okay. I'll see you next week. Try to stay safe.